Next, let's take a look at the time angle in this. So we really have the creation date for every incident. We can do things like building an incident for the number of incidents by month. This would be very useful if we had all our data. If we had data running from 2010 to today, we could look at the number of incidents by month and see if there's some kind of seasonality in these indices. We could look at seasonality by agency, seasonality by borough. We could do a lot of stuff with that. We only have 2 months data, so we can't really do that kind of stuff. But if you have the time and a fast enough internet connection to download the entire data and a powerful enough computer, actually, this doesn't require a great deal of power, but some amount of you probably need like 4 gigabytes RAM or something like that to process that all that stuff in a reasonable amount of time. You can actually run this through the entire data set. So we're going to need to do some data manipulation for this. So we want to do a month, number of incidents by month. So what we have is data that is in datetime format, and what we want to do is we want to extract from that the year and the month. So what we can do here is, luckily for us, they're all 2010, 11, 12. They are in increasing order. So we can actually just extract everything as a YYYYMM format from this thing here. And to do that, we take our created date column and apply this function to it. strf time is a function that takes a date time object and converts it into a string. And so we're going to convert our datetime object into a %y%m string. That's it, as simple as that. And we do that, and we get a new column that is data YYYYMM, and data YYYYMM becomes a new column here. And let's take a look at it. And oops, I didn't run that. Let's do the extraction. And now we see we have this nice column with the strings in it, right? So that's essentially what we do. We manipulate columns, we change them, we do stuff with them. So we manipulate this column and got this new one, and now we can do a group by using YYYYMM and agency, and let's do a graph here. And we saw earlier that 15, 15 is a bit too big, so I'm going to make this 12, 12, and we run that, and we get this by agency. So this tells us NYPD has the highest here, but in 11, the brown line, which is housing department, has gone up. 12, brown line has shot up even more, and these are the winter months, so they are the colder months. People are making, I guess, turning on their radiators and finding that they don't work. So if we see brown line goes from September, it shoots up in October and November, and then shoots really high in December, right? This is when people are realizing, hey, my heating doesn't work, and then they're complaining about it. And then it falls again in January, I guess, because by then, if you haven't got your heating working, you probably can't live there anymore. It'll be just too cold. So that tells us something over here. If you had more months, my guess is in summer, this brown line will be really, really low, because there won't be those many heating complaints. But there could be other complaints. We don't know. Maybe there are other complaints that occur in New York City housing in summer. Maybe air conditioning complaints go up. I don't know, right? So that's worth looking at. And then otherwise, the NYPD complaints tend to go down in winter for some reason. Actually, I'm not very sure whether these are, maybe, it's hard to see though, right? This could be NYPD, it could be DOE. I'm not sure which one it is, because this one is actually a little bit darker than that. So we need to take a look at it by examining each column and seeing whether they are really the same or not. Probably NYPD. We saw the NYPD had the most number of complaints. So we can do a seasonal analysis by that. We can look at the agencies and see which agencies have the highest one. So here I really want to just show you how we can draw multiple graphs. So we could, like, for example, here we group by agency, we look at the size, and we can call this function sort values, which is a pandas function. And what sort values does is it sorts the values that it gets inside from here we get a size. So the size is going to be the number of records in each in each group, agency group, and we can sort those, and we can see that NYPD has the highest, 273, followed by HPD, 244, and DOE is really down there. So none of those are DOE. They're too low for that. And we can set ascending equal to false if we want it to be in descending order, and to true if we want it to be in, or by default it's set to true, so then it will be in ascending order. We can plot this. This gives us a graph like this. If we have many of these things, we can try to restrict them if we want but for now let's do agency borough, unstack this. Right, so this is our agency borough setup, and this tells us what we've done is we've taken the grouping of agency and borough, we compute the size here and unstack it, and then we look at the data here. So this tells us what, since we have the count, this tells us for each borough what the count is for each agency, and interestingly the 311 agency there as well. Okay, so we got all that, those counts here, and we can graph this. But what we could do is we could create a bunch of graphs. So like for example, we have 5 boroughs, right? And we want to see each borough next to each other. So what we can do is we can create 5 graphs, one for each borough, and in each borough's graph we show the agency plots, and then we put these side by side. So you get a nice set of like a bunch of subplots, and you get a very visual view of how these boroughs differ in terms of their the agencies that they complain to, right? So how do we do that? Well, what we want is a set of side-by-side graphs, right? Plots in this case. So we want to have 5 plots. So we'll do them in 2 plots in row 1, 2 plots in row 2, and 1 plot in row 3. But our frame has to have 6 boxes because it has to be symmetrical, right? So we need 2, 2, 2. So what we're going to do is we're going to say we have 2 columns in our graph plot, and you know what? Let me draw it and we can take a look at it. We get something like this, right? So we say we have 2 columns and 3 rows. So the 3 rows are we have Bronx, Brooklyn in row 1, Manhattan, Queens in row 2, and Staten Island in row 3. So this is the easy way of comparing stuff. And then once we set up that, then we use my matplotlib's pyplot to create a figure, and the figure contains subplots. So subplots, each of these is a subplot. Bronx, Brooklyn, these are subplots, and each subplot is in a particular each subplot will be in a particular location, and we tell it how many subplots we want. So there are 2 columns and 3 rows of subplots, and the entire figure is 12, 12 in size. Again, that's something you can control. So it'll fit all 6 subplots into 3 times 2, that is, subplots into a 12 by 12 figure, right? And then we go through our subplots by we enumerate the agency borough iter item. So let's take a look at what that is. That will make it pretty clear here. Third cell above. It's going to essentially enumerate all the stuff that we have here, and that's that. Okay, let me do it like this. For I, comma, label, comma, call, in enumerate, because agency borough iter items is a iterator, it's not going to have values. Enumerate this, print I, comma, label, comma, call. So we see what happens here, right? So we get I is 0, and then we get the columns for that are, the label is Bronx, and the agencies are all of these are the calls, right? So we're getting 0 Bronx 311, 0 Bronx DCA, 0 Bronx DEP, etc. Okay, so we get this whole setup over here. So that's what this is producing for us, the enumerate. So this gives us our various values of I, label, and column. So we set up the axes, and what this tells us is where, for each I, where the plot is going to go. So that's what this one tells us here, right? And this locates it, right? This is the division of the 2, and the remainder are divided by the 2. And then we sort the values of the within this here. So we get, these are the values that we are sorting, right? The agency counts. So we sort those values, and we pick the first 5. Okay, that's what this is saying here. Remember, we slice it, right? So we pick the first 5, and then we put it inside a bar chart and give it the right axis location, and set the title for the axis. For each one, will have the title as the label, which is Bronx or Brooklyn or Manhattan or whatever, and which was this over here, right? That's the label, Staten Island. Right. So that's the label. Remember, this was I was. We were getting I. That's label, and that's call. Okay. So in our thing here, I label column. So we get that, and then set the label to that, and then just, that's it. It'll automatically it'll automatically display it, and it comes up here, and we get this stuff here. We get this. So we can look at this thing and try to see whether there are some differences across boroughs. And we see that here in Bronx, in Brooklyn and Manhattan and Queens, the NYPD has the most number of complaints, but in Bronx, the NYPD actually is lower than the housing department complaints. HPD is high in Brooklyn, Manhattan, in Brooklyn, the Bronx, Manhattan, and Queens, but in Staten Island, where there are very few public housing, New York City houses, it's relatively low, right? So that's what we can look at the boroughs and figure out which agencies are featured higher in terms of number of complaints and which are fewer.